For our next section of notes, we're going to look at some examples where we can mix together our factoring methods. So the questions that we're going to look at are going to have more than one step of factoring. So far we've done questions where we could factor out a GCF, we've done questions with difference of two squares, and we've done trinomials that we factored with the grouping method. In the questions we're about to do, there might be two or maybe even all three of those in the same problem. Typically, you want to go through these in that same order that we learned them. So when we try to factor 2x squared plus 2x plus 60, first we want to look for a GCF. 2x squared, 22x, and 60, those are all divisible by 2, so I have a GCF of 2. Remember that factoring out a GCF is the opposite of distributing. So to figure out what's left in the parentheses, you ask yourself, what would you distribute this to? So we would do 2x squared times 2 times what is 2x squared, 2 times x squared is 2x squared. 2 times what is 22x, 2 times 11x is 22x. 2 times what is 60, 2 times 30 is 60. Now we're looking at just the part in the parentheses. We're going to ignore the 2 for a short amount of time, and we're going to figure out how would we factor the part that's in the parentheses. Well, the part that's in the parentheses in this question is a trinomial. So I'm going to come off to the side, and I'm going to factor this trinomial, and then I'll put that into my problem when I come back to it. Now, for trinomials, remember this is the one where you're looking to figure out, compare it to ax squared plus bx plus c, and figure out what two numbers multiply to ac but add up to b. In this question, a times c would be 1 times 30, so ac would be 30, b would be 11, and I would try to think of the two numbers that multiply to 30 but add up to 11. If I couldn't think of them, I'd make that list 1 times 30, 2 times 15, 3 times 10. 5 times 6 are the two numbers that multiply to 30 but add up to 11. So I'll replace the middle term with those two values. So now I've got 1x squared, and then instead of the 11x, I'm going to have a 5x and a 6x. Then I do my grouping. I put the first two terms together and the second two terms together and factor out GCFs. X squared plus 5x has a GCF of x. When I factor that out, I'm left with x plus 5. Copy the plus sign. 6x plus 30, that has a GCF of 6. When I factored that out, I'm left with an x plus 5. So my common binomial is x plus 5. When I factor that out, I'm left with an x and a plus 6. So x squared plus 11x plus 30 factors into x plus 5, x plus 6. So back over here in the original problem, I've got the 2 out front, and then the x squared plus 11x plus 30 factors into x plus 5 and x plus 6. And then this all together is my final answer. Remember that you could check your solution by distributing, and if you get the problem that you started with, then you would know that you had done that correctly. So if I were to do a quick check, remember that when you multiply, it doesn't really matter which order you multiply in. So let's multiply the two binomials together first by distributing. And I'm just going to leave the 2 out front for a while. So when I distribute that, I'd get x times x is x squared plus 6x plus 5x plus 30. I'd combine my like terms. I'd get x squared plus 11x plus 30. And then finally at the end I would distribute the 2. And I do get my original problem, so I know that my answer is correct.